All right. You ready to dive into some seriously mind-bending stuff today?
Oh, yeah.
We're tackling quantum physics,
Right.
the science of how the universe works
Right.
at the smallest level.
Yeah.
And our guide for this deep dive
Okay.
is the source, quantum physics, explained in very simple terms,
Sounds good.
which, trust me, we'll need.
Yeah.
Ever wonder what's really going on inside atoms? Or why things get so strange down there?
Definitely.
Well,
Yeah.
we're about to find out.
Okay, let's do it.
So,
Yeah.
first things first,
Right.
what exactly is quantum physics? I mean,
Yeah.
I know it's about tiny particles, but is it all just equations and microscopes?
Well, it's definitely about tiny particles.
Right.
The building blocks of matter and energy.
Mhm.
But it's more than just equations.
Okay.
It's a completely different way of looking at reality.
Okay.
Imagine
Yeah.
you're used to seeing the world like a
Yeah.
perfectly ordered clockwork mechanism. Then you discover quantum physics. And it's like finding out
Yeah.
the gears are actually made of clouds of probability.
Probability cloud.
Yeah.
Wow.
It's a big shift in thinking.
That sounds pretty wild.
Yeah.
So how did we even discover this strange world of quantum physics? Our source mentioned a guy named Max Planck.
Yeah, Max Planck kind of kicked it all off
Okay.
back in the early 1900s.
Right.
He was trying to understand something seemingly simple.
Okay.
Why hot things glow different colors at different temperatures.
Oh, like how a stove burner goes from red to orange as it heats up?
Yeah, exactly.
Yeah, I've always wondered about that. It's like magic.
Well, Planck realized that to explain this color change, energy couldn't just flow smoothly like a river.
Okay.
Instead, it had to come in tiny, indivisible packets, like little bundles of energy.
Okay.
He called these packets quanta.
Quanta.
It was a radical idea at the time.
So like instead of pouring water from a pitcher, it's more like throwing tiny water balloons.
Yes.
Each one has a specific amount of water.
Right.
You can't divide any further.
Exactly.
Right.
And a few years later,
Yeah.
Einstein came along and applied this idea to light itself.
To light itself.
Yeah.
Okay.
He said that light isn't just a wave. It's also made up of these little energy packets.
Right.
Called photons.
Okay, so energy comes in tiny packets.
Yeah.
Light is maybe these packets too.
Uh-huh.
I'm starting to see where things get weird.
Yeah, it gets weirder.
What else is there?
Well, things get even weirder when we talk about wave-particle duality.
Wave-particle duality.
Yeah.
Okay.
This is where the whole probability cloud thing comes in. You see, in the quantum world,
Right.
particles like electrons don't always act like little balls of matter.
Okay.
Sometimes they behave like waves.
Waves.
Yeah.
Okay.
Spreading out over space.
Wait. So an electron can be in multiple places at once.
Well, it's not exactly that it is in multiple places at once.
Right.
It's more like
Yeah.
it has the potential to be in multiple places.
Let's
It's like,
find out.
imagine you flip a coin
Right.
before it lands.
Yeah.
It has the potential to be heads or tails, right?
Right.
But once it lands,
Yeah.
it's definitely one or the other.
Okay.
Electrons are kind of like that.
Okay.
But instead of heads or tails,
yeah.
it's about where they might be found.
So it's about probability rather than certainty.
Yeah.
Definitely different from how we normally think about things.
It is.
Okay, so
Yeah.
this leads us to another mind-bending concept,
Uh-huh.
the uncertainty principle.
Right.
This was discovered by Werner Heisenberg.
Yeah.
And it basically says
Yeah.
you can never know both the exact position and the exact momentum of a particle
Right.
at the same time.
Yeah.
Hold on,
Yeah.
momentum,
Uh-huh.
like how fast something is moving.
That's part of it.
Okay.
It's more like the oomph behind a moving object.
Okay.
A bowling ball rolling down the lane
Okay.
has more momentum than a tennis ball
Right.
moving at the same speed because it's heavier.
Okay, I get it.
Yeah.
So Heisenberg is saying we can't know both the where and the oomph
Yeah.
of a particle at the same time.
That's right.
Why not?
Well,
Is it just because our instruments aren't good enough?
nope.
Okay.
It's not a measurement problem.
Okay.
It's a fundamental limit
Right.
built into the universe at that scale.
So it's like
Oh.
the very act of trying to measure one of those things messes up your ability to measure the other.
Yeah, exactly.
So the more we try to pin down a particle's location, the less we know about its momentum,
Right.
and vice versa.
Yeah.
That's frustrating,
It is.
but also kind of cool.
Yeah, it is cool.
It leads to some pretty profound implications
All right.
for how we understand the universe.
It does.
So are you ready to tackle the 5 key takeaways?
I am.
Our source highlights about quantum physics.
Let's do it.
Hit me with them.
Okay.
I'm ready to have my mind blown some more.
All right. First up is quantization.
Quantization.
We've talked about how energy comes in packets.
Right.
But it turns out that's not all.
Okay.
Many properties at the quantum level are quantized.
Okay.
Mass charge.
Yeah, okay.
Even space and time.
So everything is chunky.
Yeah.
Not smooth.
Exactly.
I'm starting to see a pattern here.
Yeah.
Okay, what's number 2?
Second,
Okay.
Newtonian physics.
Right.
The stuff that works so well for describing our everyday world
Yeah.
just doesn't cut it at the subatomic level.
Okay.
It's like trying to use a hammer to fix a computer.
Right. We need a whole new set of tools for this quantum world.
We do.
What else is there?
Third,
Yeah.
these particles can exist in different states,
Okay.
each with specific properties,
Okay.
like energy and momentum.
Okay.
Think of it like an electron can be in an excited state.
Okay.
That's when it has higher energy.
Right.
Or a ground state.
Yeah.
Its lowest energy level.
Mm-hmm.
It's like climbing up and down a ladder,
Okay.
each rung representing a different state.
Yeah. So particles have energy levels.
They do.
Kind of like a video game character.
Yeah, kind of.
That makes sense.
Okay.
What's number 4?
Fourth.
Okay.
We've already touched on this.
Yeah.
But light itself is made of these quantized energy packets called photons.
Right. The tiny water balloons of light.
Exactly.
Okay. What's the last one?
Finally, there's the Heisenberg uncertainty principle.
Right.
It's not just about position and momentum.
Yep.
It means there's a fundamental limit to what we can know about a particle.
Mm-hmm.
The quantum world is all about probability and possibilities,
Okay.
not absolute certainty.
So after this deep dive,
Yeah.
I'm starting to see the world a little differently.
Uh-huh.
It's like everything is a bit fuzzier
Yeah.
and less defined than I thought.
And that's the beauty of quantum physics.
It is.
Yeah.
So.
It challenges our assumptions about reality
Okay.
and opens up a whole new way of understanding the universe.
You know, it's kind of amazing to think that all these quantum phenomena are happening all around us constantly,
Yeah.
even if we can't see them.
Right.
It's like
Yeah.
there's this hidden world
Uh-huh.
operating by its own set of rules,
right
beneath the surface of our everyday reality.
Exactly.
That's a great point to end on.
Yeah.
So you've officially dipped your toes into the quantum pool,
I have.
and hopefully
Yeah.
you're as intrigued as I am.
I am.
So
yeah.
if you want to keep exploring, think about this.
Okay.
What if our everyday reality is just the tip of the iceberg, a tiny slice of what's really going on in the universe?
That's a good question.
There's so much more to discover.
There is.
Keep those quantum thoughts flowing.
I will.
All right. Thanks for joining us for this deep dive.
Thanks for having me.
Until next time.
See you then.